So now we're going to just practice doing a lot of stuff that we do with functions. So in this case, we will take numbers, we'll plug them in, we'll take expressions, plug them in and simplify. Just kind of do a variety of things. So here I have f of x equals x plus 3, g of x equals x squared plus 1, and h of x equals 3x. So I've got 3 different functions defined, and I'm going to use all of them. So here it's g of negative 3. That means I have to plug negative 3 in for x in the g function. So negative 3 squared is 9, 9 plus 1 is 10. B, I've got a couple of those things that I have to do, plugging in, and then I have to multiply 1 by 2. So first I'll plug in 4 for f, so f of 4 is 4 plus 3, so that's 7. Then I got to do h of 1. h of 1 is 3 times 1 is 3. So now I have to take 2 times that value, which is 7, minus that value, which is 3. So that would be 11. Next, I have to do h of x plus 1. Now I have an expression. It's not just a number, so I have to take x plus 1 and plug it in for x. 3x plus 1. And it says simplify out the parentheses. That just means we have to distribute to be done. All right, here we'll do the same thing with our 2x. We'll plug that in for x in the g function. So that would be 2x squared plus 1. 2x squared is the same as 2x times 2x. So 2 times 2 is 4. X times x is x squared. So that is that simplified. Last I have x plus h, which I'll plug in there. X plus h squared plus 1. Here it's a binomial, so instead of, when I take it times itself, it's x plus h times x plus h, and I have to FOIL that. So x times x is x squared, xh and xh, there's 2 of them, and then h times h is h squared. So that would be my final expression for that one. Example 2. It says find all real values such that f of x equals 0 if this is it. So we have to find when the function equals 0. So I'm going to take the function, write it down, and set it equal to 0. This says set it equal to 0. So now I have this. And because it's cubic, I know I'm going to have probably 3 answers. Hopefully they're all real. And I have to factor this. Well, with 4 terms, I'm going to use my special factoring technique where I cut it in half, and I factor the first half, and I factor the second half. So when I factor the first half, I'll take out the greatest common factor, which in this case would be x squared. When I factor the second half, it looks like the greatest common factor would be negative 4. The reason I took out a negative 4 instead of a positive 4 is I really want these to match. And when I take out a negative 4, they match. So now what I'm going to do is look at this as a term and this as a term, and look at what those have in common. They both have an x minus 1. If they both have an x minus 1, I can factor out my x minus 1. And then whatever's left goes in the parentheses. So now it's factored. Now I can get my values. Here, this factor gives me 1, and this one gives me plus or minus 2, positive or negative 2. Here I have directions that say find the values when they are equal, which basically means find the intersection point. So I have to set this equal to this. It says set f of x equal to g of x. So I'll take x squared and set it equal to x plus 2. And then I have to solve. Since it's quadratic, I have to factor. I'll get everything to one side, and I'll factor. Looks like I'm going to be 2 and 1, negative 2, positive 1. So my values would be 2 and negative 1. All right, last, domain. When you're looking at domain, if you just have a polynomial, which means no fraction, no square root, just these, x to the something and nothing weird about it, then it's all real numbers, and I'm going to write it like that. It's like an R with a double line. And that, if you know the graph of this, is just a parabola. That means all domain, if you look anywhere, you'd look up and you would see the parabola. When you have a fraction, it's a little bit different. When you have a fraction and you think of it like, what could I plug in for x? You can plug anything in for x except what would cause you a problem. And here, if you have 2 minus 2, oopsie, you would have 0 on the bottom, and you can't divide by 0. So the one number here that would cause a problem is x equals 2, because 2 minus 2 is 0. So here I would say all reals except x can't equal 2. And that's how you write it. You write all reals, comma, means except x can't be 2. But it could be anything else. Here, the trick is here that I have to have a 0 to square root or a positive number. If I end up with a negative number under the square root, I couldn't do it. Okay? So I need to have a positive number or a 0 in order to square root. So what I do is take this x plus 2 and say it has to be positive or equal to 0. It has to be positive or equal to 0 in order for it to work. And then I'll solve this. Subtract 2 from both sides. And this says my domain is all x's if x is greater than or equal to negative 2 will work. And if you're not sure, you can pick a number that's greater than negative 2, like 0, and plug it in. No problem. If you pick a number less than negative 2, then you have a problem. It's a negative 1.